All right, so we have this from the previous example. If you didn't see it, go back to that one. It'll be listed at the very end of this video as one you can go back to. So we have these, which test our IP addresses. I got one with some leading zeros here. I'm going to go ahead and add a few other IP address to 32-bit unsigned int conversion tests. So, video magic, and all right, I added just one more, but here is what I want to do with AI. So I'm going to go down and I'm going to turn on my Copilot, and we're going to use Copilot again. Open, enable completions. All right, so what I want to do is actually write a test, pose void test IP address reservation identification, like that. And then let's see if it'll be interesting to see if Copilot starts to come up and tell me like what I'm trying to do here, because that's already the first clue. So assert that IP convert dot IP use reservation. And we're gonna do an IP address here, which let's do one. Oh, what is? Let's do 0.0.0.0. Is dot equal to. And we want it to say we're gonna. So there's these different reservations that IPs can have. There's a per reservation range, right? So like there's a local network, or this IP range, and that is the first intro IP range. And just for reference, I'll show you what I'm looking at here. I pulled up another page right before this, and I was like, oh yeah, let's get reservations, and here it is. Okay, so this is a Wikipedia page on IPv4. We go down here, addressing, and we get into the special use addresses, okay? So this range, 0 to 0.255.255.255, blah, 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 is the local network. It has a billion of these, okay? So, and then you got private network, though. 10.whatevers to 10.whatevers. Used for local communications within private network. So, like, in this range, I want it to identify as this, right? And so on. Like there's different ranges, whatever, and they're designated like this with the mask there. All right, so one of the things we could do too, I guess we could do just like give me the address block. If I do this, what's the address block for it, right? That actually might be more interesting to calculate. So let's do that actually. Forget this. Let's do address block. And we'll do z.z.z.8 is equal to, let's see, your number of addresses. So that would be 16,777,216. And I'm just copying that number from Wikipedia. I got assert dot, oops. Well, let's make another test. We'll call this one test IP address, the address block range for 0. And then test public void test IP address. Let's do. We'll do the IP block for the IETF protocol assignments. Address block for IETF protocol assignments. That. And then we got IP convert dot, what was our method? What did we call it? Address block And in there, we're going to have, let's see, 192.0.0.0/12. No, I mean 24. That's what it is. So, and then here, I want that it is equal to 256. Okay, so now I'm going to do this, create method, and this is just going to come back as, let's do int, or no, we need to do unsigned, uint 32, but oh yeah, it'll tell us to do just an unsigned int, right? Yep, okay. So there we go, and then the string is actually the IP address. And then in here, we want to return IP address.split select aggregate. Okay, that's what I just did. That's not what I want. Let's hear it. Let's do address block. Let's see if I can do like calculate. Yeah, the number of addresses in the block. So then do var ports. IP address split, yep. Okay, var block parts. Parse one. Block address. Block mask. Oh my god, is this... Did it just piecemeal out the thing for me? That might work. That might work. Let's go back and look at our test real quick. So this one's going to give us that many, and that one's going to give us that many. What's another one? Oh, there's like the 10 dot range. And then there's there's host for loopback addresses for local hosts. So let's add that one too. Test public void test IP address to block for local, call it link local address. That'll be assert that convert dot address block the IP, which is 169.254.z.z/16, and then is that right? 65536. So yeah, it seems to know. All right, let's see here. Is that one going to be right? And 536. What is expect but was a big number? Okay, and let's see if it does it pass this one? No, of course it doesn't. All right, so we got to figure out what's wrong with that then. All right, so we got a bunch of failures here. We expected 256, but we got some crazy number. We expected this, and yep, some crazy number. And yeah, wait a second. Are they all this? Oh, they're all a little different. But yeah, so obviously the implementation is not correct. Let's see here. How do we do the GitHub code brand? Right. Where is the... That's not what I wanted. I want the GitHub thing where you type in it. GitHub Copilot, right. Refresh. Oh, and this is, oh yeah, these are correct. These are the numbers there. But it doesn't seem to have did the math right. Which kind of makes sense because it's like, what is this? What did this actually do? Calculate the number of addresses in the block given the IP address and the subnet. Calculate the number of addresses in the block based on the block size. Address range, address block. The block that has it in there. Calculate the number of addresses in the block. So I want to type in, oh yeah, GitHub Copilot chat. Yeah, okay, so let's just ask it, how do you calculate a block of a range of IP addresses available from an IP address block? It's got little green checkboxes. That's cute. Calculate average. You need to understand the concept of subnetting and CIDR notation. Yes, I know. This is the CIDR notation. So y in the subnet mask y represents the number. Da, 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 da. Right. So, wait. Oh, did this just... Here's how to do it. Okay. Wow. Did it just literally... Oh, should I rename it usable addresses? Let's take this part. And we'll do this. And then let's actually refactor that and call it usable addresses, because I like that naming better. Where's my refactor? Oh, here it is. I feel like it moved. I feel like it was up above there. Usable addresses. There we go. Now, I'm not even going to look at what it gave us. Just let's go see if we get a right answer now. No, still some... What? It's only off by like 2. Oh, because... Well, wait. Okay, subtract 2 for network and broadcast address. Right. So that makes sense based on the IP addresses. So this is usable addresses. So then there'd be another calculation. Yeah, okay, so that's actually right, because the usable addresses, what is it? You take the first and the last one, and you don't use those because that's like the... I completely forget what that is. My network knowledge is failing me. But anyway, you take 2 off because you take like the first and last one of the range, and they have special meaning. But that calculation is correct. So let's see how close the other ones get though. All right, run them all. And there we go. Is it all off by 2? Yeah, okay, perfect. Let's go back to the implementation. Usable addresses. Go to declaration or usage. There we go. Let's do that, and then let's do how should we do this? Let's do another one. Just call it public static uint address block. Let's call it that. And then is it going to do the same thing minus the... Oh, it did. It did exactly what I was thinking. It took out the usable addresses, which is what I wanted to do. So then what we could do here is, let's take this and let's go here and let's actually just do this. We'll do address block. We'll pass in the IP address, and then we'll -2 it, and boom, there we go. So that's the calculation for that. And let's get back over here and fix these tests. So this would actually, we would be testing the address block. Whoops, nope, come back here. And then I didn't really need to do that, but let's test the usable addresses right below that. Usable addresses, and we'll just make it 2 less, like so. All right, so this one, there we go, and then this one. Whoops. Obviously, those are gonna work too. I mean, it's simple freaking math. You don't even really need to test it. You just need to test the one method. But just for completeness and for it being descriptive, I'm sticking these in here like this, right? Okay, so yeah, that all should work. Let's run these tests. And we have success. All right, so we've just added via Copilot a new feature set to our IP converter of two methods, actually. We have usable addresses and we have address block, which takes the IP address, snags the block, the CIDR block element off of the IP address, and then calculates parts. Yeah, mask that, and then you just call it a mask. You call it the CIDR mask or the block mask. Anyway, and then you get the power of 232. Oh yeah, that's a good way to calculate it. That's like one step using the math library. I have used the math library so few times in .NET, and I bet if I had had Copilot a million years ago when .NET came out, I probably would have used the math library a lot more because I would have known what was in it, but I often did not know what was in it, so I just wrote the math out. Anyway, and that gives us the total addresses. Calculate total address in the block, and then usable addresses. All right, cool. So there we go. We have the usable addresses now in the address block, done by Copilot. Now, it was interesting, though, that initially the Copilot kind of gave us some like weird fluff code, one line at a time, and that didn't really quite do what we were trying to do. Even though I am partially to blame because I didn't use good naming with the name of the method. If I had named the method right, it probably would have given us something like this right here to calculate it with. So it really, this kind of stuff really drives home the point when you're using Copilot. Like, you have to name the methods something that is indicative of what you intend the method to do. You have to do that if you want Copilot to give you anything intelligible, which completely makes sense, really. And in all reality, since we write code for us humans, we should be naming them something that makes sense, like usable addresses or address block, instead of arbitrary nonsense, which often still happens far too often. So yeah, that was pretty good. It was weird that it kind of goofed up at first, but then it quickly righted itself as long as we did a little chat. And I think like that combination, it seems like they've actually gone through some good usability there, usability experience or developer experience, and kind of figured out a good balance and back and forth to get that. I feel like, however, myself, I usually start from the conversational perspective when I use AI, when I have used AI tooling in the past. But with these videos, it has changed, and I've actually started to do more write a test to force the AI thing to kind of sort out what I'm trying to do and give it a criteria in which it needs to implement the code, which is kind of interesting because it's kind of like TDAID development, right? Or test-driven artificial intelligence tooling development, or if we want to be really serious, test-driven probability-based engine math development. Anyway, with that one was pretty cool. I like how it turned out. I think that's a pretty solid method, along with this that I just crammed through. That one's pretty solid too. So with that, I'm going to catch you next episode. Hope that was some good stuff. Again, if there's any programming problems out there that you would like to see me solve in these sessions, let me know and I'll put it into my queue. And hell, I'll even do it in whatever language you want me to do it in, except Rust. Nah, I'll do it in Rust too, maybe. Just throw whatever language at me and I'll try to implement it in there. Yep, that's that. See what we can do. In the meantime, everybody, happy thrashing code. Keep it compiling. Cheerio.